In this video, we're going to again talk about existence of the limits in some of these multivariable or several variable functions. So one thing we know is that for a limit to exist at a point, the limit must be the same along every approaching path. So this compares to our single variable limits in Calc 1 and Calc 2, where the path from the left and the right had to match. And I know I've mentioned this previously in one of our former videos, but I just want to impress upon you again this two-path test for non-existence of a limit. So if a function has different limits along two different paths in the domain of the function, as some point on that disk approaches the specified point, then the limit doesn't exist. So now we can look at an example. So for this example, we're going to show that the function f of x, y, equaling 2x squared y divided by the quantity x to the fourth plus y squared. We want to show that the limit does not exist as xy approaches 0, 0. Or rather, we're going to show that the limit as xy approaches 0, 0 of f of xy does not exist. All right, so first thing we try to do would be to plug in 0, 0 to the function. And of course, if I do that, I end up with 0 over 0, which is an undefined value. And then we look and say, well, can we manipulate this to cancel something? And there's nothing readily available to factor or to use our algebra to manipulate it. So we can't substitute, we can't reduce any factors. So we're going to need to consider different paths. And in this example, we are going to consider the path of different parabolas. So what that means, we're going to look at parabolas y equals k x squared, as long as, x doesn't equal 0. We can't let x equal 0 because then it's not a parabola. So different parabolas with different coefficients. K is just some integer value. So we have our function. The first thing we're going to consider, the path, would be y equals x squared. So I'll take my function that was given, and I'll rewrite it here just so we have it for now. We've got 2x squared y over x to the fourth plus y squared. So if I take that function and I let everywhere there's a y become an x squared, let's see what happens. That would give me my new function is 2x squared over x to the fourth plus x squared squared. So this gives me, as I simplify, 2x to the fourth over 2x to the fourth. My function would then simplify to 1. So this function's all in terms of x's, and so now we would be looking at the limit as x approaches 0, because again, that's what we had up here. We had x equals 0 and we turned it all into x's, so the y is gone. As x approaches 0 of this simplified function, which is 1, so that limit is 1. Further, let's look at another path. Y equals 2x squared. So I'm using a different x squared function. And if I take those 2x squareds and I plug them in for my y values, my new function is 2x squared times 2x squared over x to the fourth plus 2x squared squared. So this simplifies to 4x to the fourth, 4x to the fourth over 5x to the fourth, or 4/5. So the limit as x approaches 0 of 4/5 is 4/5. So I'm turning it into these constant functions. And just to be, extra rigorous, let's look at what happens if I said c, y equals 3x squared. What does that do to my function? So I'd take my function and would say 2x squared times 3x squared over x to the fourth plus 3x squared, and I end up with 6x to the fourth over 9 plus 1 is 10x to the fourth, or 3/5. So again here, the limit as x approaches 0 of 3/5 is 3/5. So by plugging in these different paths, I could see that I'm getting different limit output values, and if the limits along these different paths do not match, then we can say the limit does not exist. And I like this example. I did this one from the book because there was a really nice visual of our function, and you can kind of visualize these different parabolas that we have considered here. So here is my function, and you can see all of these parabolic paths lying on those xy planes within the function. So this yellow curve represents y equals x squared. The green curve represents what I just drew here, y equals 3x squared. And you can see that these paths are not going to the same value. And because they're not all approaching the same value, again, we say that the limit does not exist. So just reiterating, all of these paths, when I plugged in those functions, none of them are they're not touching anywhere. None of them are going to the same path. And because they're not going to the same point, I should say, then the limit doesn't exist. So I've repeated myself like 5 times. I hope you guys are having fun, and I hope you have fun out in the math world doing this on your own. Good luck.